One is called like linear method or model soups, and the idea is just to average the weights of the model. It could be a weighted average as well. It's pretty simple. And the authors of the paper did it in the context of accelerating training. So they were merging different checkpoints of a model to get to a much better model faster without spending so much money on training. Then there is a very similar method called SLERP, so Spherical Linear Interpolation, that you could use for merging only two models. You cannot merge more than two models, and the idea is like to create like a smooth transition, a smooth interpolation between the weights of those models. It works quite well in practice when you have only two models. And then there are methods based on task vectors. So task arithmetic, and then there's task merging, and there. A task vector is basically, like in simple terms, is like the difference in the weights between the fine-tuned model and the pre-trained model that was initialized at the beginning of the fine-tuning. And then what you do is you compute that task vector, and then you could do operations with them. And normally, if you want to add more abilities to the model, you add them together, and then you kind of put them back into the pre-trained model. And in this way, you change like the behavior of that initial model. And then the other two methods that are based on this, that I already mentioned, there and TICE, they try to address possible interferences in the model parameters. For example, a possible interference is that the sign of one vector is different from the other one. Then what do you do? What they basically do is like they prune a little bit the task vectors, and then they try to address those interferences. Finally, there's like quite an experimental method that is called layer stacking or frankenmerging. And there what you are doing is just concatenating layers, creating a new architecture. So you could say, I want 5 layers from this model, then I want 8 layers from this other one. And that results in quite exotic model sizes, like 160 billion parameters. Normally, you know that we have 70V, perhaps 34 billion parameters, then 70 billion parameters. But then if you do these frankenmerges, then it's going to result in, I don't know, like 64 billion parameters. It's quite experimental, but we've seen like really good models produced by this technique after running many experiments. One really good one is Goliath, 120V, MiQ as well. So yeah, very interesting.